China is building the world's biggest airport in the middle of the ocean. What if I told you that right now, as you are watching this video, a team of engineers is literally stealing land from the ocean? Not a small island. We are talking about 21 square kilometers, an entirely new piece of earth being built from scratch in the middle of the sea, bigger than Monaco, almost the size of Manhattan. And on top of it, they are going to land jumbo jets. This is the Dalian Xinjinwan International Airport. And it is not just the world's largest artificial island airport. It might be the most ambitious construction project happening on this planet right now. Stay with me, because the why behind this project is just as insane as the how. Let's set the scene first. Dalian, a coastal city in northeastern China, 6 million people. One of the country's biggest shipping hubs, a major oil refining center, and a critical trading gateway between China, South Korea, and Japan. This city never sleeps. Commerce never stops. But here is the problem. Dalian's existing airport, the Zhaoshuizi International Airport, is ancient. We are talking 1927 ancient. It was originally built during Japanese occupation on what used to be a horse racing track. For decades, it served the city just fine. But then Dalian exploded. By 2012, the airport was handling 13 million passengers every single year. By 2018, that number jumped to 18 million. And the projections for the future: the city needs capacity for 70 to 80 million passengers annually. The old airport simply cannot do that. And here is the worst part. It is completely boxed in. Hills on one side, dense urban neighborhoods on every other side, shaky, unstable soil underneath. There is literally nowhere to expand. Engineers tried 4 separate times. Expansion attempts in 1992 and 1993, in 2005, and again in 2011. Every single one hit a dead end. Imagine you are a passenger on final approach into Dalian. You look out the window and you see apartment buildings so close that you could almost count the floors. That is how tight it had gotten. So the decision makers faced a brutal choice: demolish thousands of homes and cut through mountains to expand the old airport, or do something completely different. They chose different. Here is the bold call: build a brand new airport 25 kilometers from the city center, entirely in the sea. The site sits between the Bohai Gulf and the Yellow Sea. The water there is about 10 meters deep. And the natural conditions? Let's just say nature did not make it easy. Typhoons roll through that region regularly, generating waves up to 8 meters high. That is a 3-story building made of water, crashing directly into your construction site. In winter, the sea literally freezes. Ice flows can stop ships cold, shutting down supply lines for weeks at a time. And if that is not enough, the entire region sits in a seismic zone. Earthquakes are not a hypothetical here. They happen. So why would anyone choose to build there? Because when you have no land left, the ocean stops being an obstacle. It becomes an opportunity. Site selection for this project started all the way back in 2003. The project was included in China's 12th five-year plan in 2011. But land reclamation was stalled until 2016, and the full groundbreaking ceremony did not happen until 2023. Some projects take time, and this one needed every single second of that planning phase, because what they are attempting has never been done at this scale before. Not anywhere in the world. Let me give you the raw numbers, because they will genuinely break your brain. The finished island will cover 20 to 21 square kilometers. For comparison, Kansai International Airport in Japan, which was considered revolutionary when it opened, sits on just 10.5 square kilometers. Hong Kong's Chek Lap Kok Airport covers 12.5 square kilometers. Dalian is bigger than both of them combined. The total material needed just for the land reclamation alone is 400 million cubic meters of sand, rock, and that is enough material to bury the entire city of San Francisco under 30 meters of earth. Every single load of that material arrives by barge. Every layer is precisely placed, then compacted by heavy machinery, then tested, then compacted again. The total cost sits at around 4.3 billion US dollars, and it is climbing. The first phase alone targets 31 million passengers per year, 2 runways and 400,000 square meters of terminal space. And the full build-out? 4 runways, 900,000 square meters of terminal, 80 million passengers per year, 1.5 million tons of cargo annually, over 5,400 flights every single day. That would put Dalian in the top 10 busiest airports on Earth. Now here is where it gets really fascinating, because building on the ocean floor is nothing like building on land. Not even close. The first and biggest challenge is that the ground itself does not exist yet. Engineers have to create it. Layer after layer of material is placed on the seabed. But soft marine sediment is basically unstable mud. If you just stack material on top of it, it sinks. That is exactly what happened to Kansai Airport in Japan. Years after it opened, that airport began to slowly sink into the sea. They spent millions and millions of dollars on sand drains and special concrete structures trying to stabilize it. Dalian's engineers took that lesson very seriously. So here's how they are solving it. The first method is pile driving. Massive steel piles are being hammered deep into the seabed. Some of them go down 80 meters. Think of these as giant nails anchoring the entire island to solid bedrock beneath all that soft sediment. The second method is deep cement mixing. Specialized machines inject a cement slurry directly into the soft soil. This chemically bonds with the mud, turning unstable mush into rigid load-bearing columns underground. They are essentially creating artificial rock beneath the surface. The third method is pressure grouting. High-pressure injection seals any remaining gaps between layers, locking everything together into one unified structure. The result of all 3 methods combined is what engineers call a constructed bedrock, an artificial foundation that can carry the full weight of an entire airport, including the impact of fully loaded Boeing 777s and Airbus A380s landing at maximum speed. Then there is the seawall problem. The island has to survive those 8-meter typhoon waves. So the perimeter is not just a simple wall, it is an engineered fortress. Steel-reinforced chamber structures, interlocking concrete blocks, tetrapods, which are those large X-shaped concrete forms you have probably seen on rocky coastlines, stacked along the outer edge to absorb and break up wave energy before it ever reaches the main structures. Special anti-corrosion coatings are applied to every surface because salt water is absolutely relentless. It does not just rust steel, it destroys it over decades if you are not protected. This seawall is not just protecting a construction site. It is designed to protect a fully operational international airport for 100 years or more. Now I want to be honest about something, because a project of this scale does have an environmental footprint. Land reclamation disrupts marine ecosystems. Sediment displacement changes water flow patterns. Fish habitats get disturbed. That is just the reality of this kind of construction. There is no way around it completely. But here is what is being done to address it. The project has gone through multiple rounds of environmental impact assessments, something that was not even standard practice in earlier mega reclamation projects around the world. Artificial reefs have been deployed around the construction zone. These are specially designed underwater structures where displaced fish and marine organisms can establish new habitats over time. Transplanted marine vegetation has been carefully moved to areas outside the construction footprint, preserving local species that would otherwise be lost. Tidal channels have been modeled and engineered to maintain proper water circulation around the island, preventing the kind of oxygen-depleted dead zones that plague poorly planned coastal projects. And perhaps most importantly, real-time environmental sensors are embedded throughout the project zone. They track water quality, sediment flow, marine biodiversity, and ecological health around the clock every single day. Chief Engineer Li Xiang from the Dalian Airport Construction and Development Company has stated publicly that balancing construction quality with environmental protection is not optional. It is a design requirement built into every single phase of the project. Is it a perfect solution? No large-scale ocean construction project is, but the data-driven, continuously monitored approach here is genuinely more sophisticated than anything that came before it. An airport island that nobody can reach is not an airport. It is a very expensive parking lot for fish. So connectivity is getting just as much attention as the airport itself. Elevated highway bridges and causeways are being built to link the island directly to Dalian's existing road network. Metro Lines 5 and 1 are being extended specifically to reach the new airport, so passengers can travel seamlessly from the city center to their departure gate without ever sitting in traffic. A full multimodal transport hub is being constructed right at the airport entrance. A single unified station where high-speed rail, metro, bus, and road transport all come together in one place. The vision is straightforward. You should be able to arrive in Dalian by ship, by train, or by car and connect directly to an international flight without experiencing a single chaotic transfer moment. That kind of seamless, genuinely integrated transport design is what separates a good airport from a truly great one. Here is what most coverage of this project completely misses. Dalian Xinjinwan is not just a new airport, it is a strategic node. Geographically, Dalian sits right at the meeting point of the Bohai Gulf and the Yellow Sea. It is just a few hundred kilometers from Seoul and Tokyo. It is, without exaggeration, one of the most important maritime crossroads in all of Northeast Asia. This airport is being designed to handle not just passengers but massive cargo volumes. 1 million tons of cargo per year in Phase 1 alone. That positions Dalian as a major pillar in China's Belt and Road Initiative, the global infrastructure and trade strategy that is connecting China to Europe, Southeast Asia, Africa, and beyond. The design contract for the cargo and maintenance complex was won by KCC IPR, covering over 700,000 square meters of cargo handling facilities and 24,000 square meters of aircraft maintenance space. And there is a layer beyond economics, too. Infrastructure at this scale serves both civilian and strategic purposes. Disaster response logistics, humanitarian corridors, rapid movement of goods and personnel during a crisis. A 4-runway artificial island airport is an asset that extends far beyond commercial aviation. So when does this actually open? The current timeline projects Phase 1 completion around 2035. That delivers 2 runways, the initial terminal building, and capacity for around 31 to 43 million passengers per year. After that, Phase 2 brings 2 more runways, expanded terminals, and the full 80 million passenger and 1.5 million cargo ton target. When everything is complete, the old Zhaoshuizi Airport gets retired. A century-old facility finally put to rest, replaced by an island that did not exist a decade ago. One honest caveat, though. Projects like this face real risks. Ground settlement, unexpected delays, cost overruns, typhoon damage during construction. These are not hypothetical concerns. The Kansai Airport story showed the world what can go wrong when you build on soft seabed. Dalian's engineers say they have studied every single precedent and learned from all of them. The next decade will show us whether the engineering holds. Here is what I keep coming back to after all the research I have done on this project.